Hi students, continuation basics of the microprocessor. The next one is the stack. Stack is nothing but it is a temporary storage memory. So in the temporary storage memory, we'll access with the help of only two operations. One is the push operation and the pop operation. Push is nothing but we are going to store some information into the stack. Pop operation indicates we are going to reading or we are going to deleting some data information from the stack's memory. So stack's memory always works in the principle of LIFO. That means last in first out operation. So one more point here, stack pointer always points to the top of the stack segment. If you want to push new byte, that means stack pointer is decremented by 1. If you want to push 2 bytes at a time, 1 byte, only one location is decremented, stack pointer. If you want to push 2 bytes at a time, that means 2 times it is decremented by 2. Same as it is, if you delete only 1 byte, the stack pointer is incremented by 1. If you delete 2 bytes at a time, the stack pointer is incremented by 2. So like this here, the stack's memory always used to temporary storage device, temporary storage memory. So the stack's memory is always accessed with the help of push and pop operations. So here stack represents the sequence of objects or elements in a linear data structure format. The next one is the queue. Queue is simple, it is called as it will perform always in the form of first in first out operation. So whatever the data bytes we are receiving inside this queue, those bytes will send outside first. First we are receiving, those elements we are sending outside also first. So first input and first in and first out operation will perform. Queue is an abstract data type or linear data structure or FIFO data structure. This queue is used in the 8086 microprocessor, 8086 block diagram architecture, because here 6 bytes of queue is inserted inside the 8086 block diagram. Next one is the segment or segmentation. Segmentation is nothing but we are going to divide it into different parts. If it is in microprocessor architecture, we are going to divide into different parts. This is one part and this is one part, small part, where this simple part is called as a segment. Segment are chunks. C-H-U-N-K-S. C-H-U-N-K. Chunks are segment. Segment is nothing but out of the available part. Suppose if you want to say some particular location or some particular area. So this subpart is simply called as a segment or chunks. So in this diagram, we are going to see out of this complete circle. Suppose if you want to talk about the small area, simply it is called as a segment. The segmentation means to divide the marketplace into parts or segments. What is the advantage of the segmentation means? We are going to store different informations in respect to, that means respect to data contents into respect to locations. For example, in 8086 microprocessor, we have 4 segments: data segment, code segment, extra segment, stack segment. The stack values are stored inside the stack segment. Data segment values are stored inside the data segment. Extra segment memory is used to store extra segment values. That means string characters, like different every character. Next, code segment. Code segments, instruction code bits will store inside the code segment. So like that, every data will stored that respect to locations one, so that the overlapping of the data is completely eliminated. This is the advantage of the microprocessor execution. It is the advantage of the microprocessor architecture. Previously, we don't have any segmentation in 8085. So that is the problem is nothing but overlapping of the instructions, overlapping of the data is possible. To overcome that overlapping problem, we are going to implement the segmentation. The next one is the branch or label address. Branch or label address. For example, in 8086 microprocessor called 2000H. Let us see small instruction. It's 2000H. Call 2000H means this is a label address or branch address. What will happen? So if it is a call or label address, automatically cursor goes to that location. So here totally actually branching is classified into 2 types. One is a conditional branch and unconditional branch. So condition means if the condition is satisfied, it executes that particular program like this. If unconditional means if condition is not satisfied or without checking any condition, it executes the particular block diagram. That means block in the sense we are going to executing that particular instructions only. So here condition is true, the cursor goes to processing A block, it executes these instructions. If the condition is false, the cursor goes to this block, it executes these instructions like this. That means while it is executing, these instructions are skipped. While it is executing, these instructions are skipped like this. The branching is nothing but we are going to call in some other location. Call 2000H means the cursor automatically jumps to the 2000 location to identify the location 2000H. So from 2000H onwards, the cursor will execute the instructions one by one like this. Means it calls to the separate location. This location address is called as a branching address. This simply address is called a label address. Next one, procedure or subroutine. Subroutine procedure or subroutine or subprogram. The names are same as it is. In this case, this is a mainline program. So in mainline program, number of instructions are there like this. The cursor is executing in continuously like this. Suppose if any procedure call instruction is executed like this previous branch or label. If any call instruction is executed, that with the help of that address, the cursor automatically jumps to that location. So again, it starts the execution from that location onwards. That is called a procedure program 1. So while it is executing any another call, that means procedure call 2 is executed, again cursor goes back to the another procedure program. So again, the procedure program starts the execution from the first instruction onwards. So after completion of the complete instruction, with the help of return, cursor goes back to the previous procedure 1. So that means this is a subprogram 2, this is subprogram 1. So after completion of this subprogram or procedure 2, with the help of return instruction, cursor goes back to the previous procedure, that is called procedure 1. So again it executes the remaining instruction. Again with the help of return instruction, again cursor goes back to the mainline program and it executes the continuously remaining instruction like this. Okay. The procedure is subroutine is an important part of any computer systems architecture. A procedure is a group of instructions that usually performs one task. The next one is pipeline. Pipeline means we are arranging the instructions in the form of pipeline. For example, this is one instruction like this. This is one instruction. And this is one instruction. We are arranging instructions by instruction is like this. So, for example, here, if it is a instruction 1, instruction 2, instruction 3 instructions. So, every instruction must be follows the 3 cycles. Then only you can say that directly the particular instruction is completed. That is, cycles are fetch and decode and execution. So, same representation here. We are going to see this tabular form. Say instruction 1, instruction 2, instruction 3 and instruction 4. In instruction 1, suppose if you want to executing this instruction 1, that instruction is must be follow all these 3 cycles. Fetch cycle, decode cycle, execute cycle. Simply it is written to fetch 1, that means instruction 1, decode instruction 1, execute 1. Same as it is instruction 2, fetch 2, decode 2, execute 2. Like this, fetch 3, decode 3, execute 3. Fetch 4, decode 4, execute 4. So in this case, in row wise, we are going to see here cycles, that means clock pulses 1, 2, 3, 4, 5 like this. In this clock pulse, we are going to executing only fetch of the instruction 1. In second clock pulse or second cycle, only we are going to executing decode cycle of the instruction 1 and fetch cycle of the instruction 2 like this. At a time we are going to perform 2 cycles. In say cycle 3 cases, we are going to see here execute instruction 1, decode instruction 2 and fetch instruction 3 like this. That means instruction 3 we are going to perform or execute at a time 3 cycles. In first case only 1 cycle is executed. If we are arranging instructions or overlapping instruction by instruction like this, so the main advantage of this one, we are going to increasing the system performance, because in cycle 1 we are going to execute 1 cycle, in cycle 3 or clock pulse 3 we are executing 3 cycles. That means our system always needs to increase the performance of the system. While we are arranging the instruction like this, automatically system performance will be increases. That means time is saved. So Here, the pipeline is the process of accumulating instruction from the processor through pipeline. The instruction pipeline is a technique that is used to execute multiple instructions parallel. That means this pipeline is used to parallel processing with a delay of one clock cycle. Pipeline is a process of arrangement of hardware elements of the CPU such that its overall performance is increased. It's very, very important. So with the help of this parallel arrangement, the overall performance of the system is increased.